So for future reference, you guys have that. Okay. All right. So just to kind of continue to help you understand the way this class is going to work best, I live off of questions, my God. And I know you guys have questions. I know you do. Any questions from homework stuff? One really good question is like, where should we be? You should definitely have 1-5 done. You should be into chapter 2. Unless you're like me, when I was in college, I physically couldn't do homework during the week because I was working 3 jobs. I could only do it on the weekend. So if you're like that, I understand. But you really should have section 1-5 done. Yes, you got a question.
I was just wondering how you go about number 11 on section
2-6, number 11. Oh, that's the one. Yeah, it's perfect. It's almost like I planted you out there. All right. Yeah, okay. Weehaw. All right, there it is. Beautiful. All right, gaze upon this crazy ass problem. So let me ask you this. And no, you're not allowed to change the problem, but I'm the teacher, I can talk about a related problem. So let's say, instead of that, let's say I had this problem. Here, let me do it. You guys can all see that, right? Yes? So what if I had x squared minus 5x plus 6 equals 0? Can you guys do this problem?
Yeah.
How would you do it? Oh, look at me trying to erase the mouse. Get out of there.
X minus 3, x minus 2.
Yeah, what do you put here and here? Why? You're like, no, not y. Why do I put an x there? Because freaking x squared, chop, is xx, yes? Also notice this. The middle term is now going to be number times x, number times x. So see how the middle term has to be, I have a power that is half of the first dude. The middle term comes from number times first guy, number times the other first guy. So if the middle power is half of the first power, I can factor it like this. I don't give a shit what the numbers are. Because what do I do first? Don't I take the first dude and split it in half? So there's nothing magical about squared. There's nothing magical about it in the process we use. So this would be, I think somebody said minus 3, minus 2, right? So then my answers would be 3 and 2. Whoa. Okay. So watch this. What if I made this 8 and this 4? What if I, forget I have erasers? What do you put there and there? X4. Why does that work? Because now the middle term will have number, it'll have something x to the 4th. You guys see that? So the middle power must be half of the first power, and if that's true, I could just factor it like normal. It wouldn't be like normal. Cut it in half, find the numbers that work. So what numbers work? Now, I don't give a shit now. I got that taken care of. Now I just got to worry about the numbers. What numbers work? We already know.
-2.
Yeah, minus 2, minus 3, yes? Now, let's see if you guys are cool with the next step. The answers are not 2 and 3. For damn sure. Okay. If I have 2 numbers that multiply to be 0, what must be true about either one of them? What must be true about one of them? One has to be 0. So either this is 0 or this is 0, yes? And then you can solve those, right? Add 2, take a 4th root. You guys see that? So if I add 2 and take a 4th root, I get that funky little number. Same thing over there, okay? You guys with me? So if I would have put a 10 here, this better be 5. If I put a 2/3 here, this better be
1/3.
Okay. So the first step on this, what's going to go here and here?
1/3.
And that matches with what the middle term needs to be, yes? So that's what we call quadratic in form. It's not quadratic because it's not squared, but it acts like it because I can cut it in half and everything else flows. Is that better? Is that all right?
Yeah.
You know, like it's better because I originally had no freaking clue. So, all right, I understand. That one is weird. I agree with you. Well,
I got
really,
thrown off because the book, when I went back to look at it, said you have to use U substitution.
hell no. You see,
Yeah,
yeah.
so I
I
was-
don't need to. I love you, sub. It's awesome. We don't need it here. It actually makes it a little worse than it needs to be. Yeah. Okay. Anything else from homework stuff or general stuff? Yesterday you said this, and I didn't know what the hell you meant. Okay. Has anyone gone to the Math Science Center yet for any help for you guys? Okay. Yeah, I like it. The rest of you guys are like, I got this, no problem. Okay, okay, we'll find out. All right. So, if there's no more questions from homework, remind me what's happening Monday. Quiz. I love it. On 1.5, 2.4, 2.5. Kick ass. So you got the weekend. You should be up to at least 2.5 by Monday. What's up? Oh, okay, there you go. I love it. Kick ass. All right. Do you have to turn in homework today, Monday? Do you have to? No. When do you have to turn in homework by?
Exam.
Yeah, and even then you don't have to because you can just accept the fact that it's late. You with me? So let me have a little discussion with you guys. It's like, but that's your job, man. Make homework your own. I've assigned problems. I've assigned the amount of problems I think you need to live with an idea so you get it in your head. You have a life, I really hope, right? You have shit to do. You have jobs, you have family obligations, so forth, yes? If it gets to a point where you start to get really behind, start doing every other problem I assigned. You guys with me? Don't do the first three problems, because what's almost always true about the first three problems, they are the easiest ones. Are you getting good practice then? No. So if you don't have enough time to do every single problem I've assigned, don't do every single problem I assigned. Am I saying I'm going to give you full credit? Nope. I'm going to say finish this. No, I'm going to say what the shit. I'm going to say finish this, whatever. You with me? And then if you have time, you finish it. And if you don't, you don't. The most important thing for homework is to get you ready for the test. If you come to the test and there's entire sections you haven't looked at all, you're going to die on these problems. It doesn't make any sense to me. So you want to get practice from every section of the most number of kind of problems you can. You with me? Dear God. So if you ever get, well, I can't do every damn problem. Don't. Start skipping some. I'm going to tell you to finish it. I'm going to give you half credit, but you're going to do what you can to get ready for a test. Trust me, that's what the hell I did. The teachers that counted homework for a lot, I kind of got worse grades. I like to say my report card had personality. I didn't get, I got, you know. You guys kind of with me? Okay. And I didn't care that much because I wasn't a med student. Med students have all this unnatural freaking requirements and bullshit, but I wasn't that. I just needed to pass, and I kicked ass on the test, and my homework suffered. Because I got 3 jobs. Leave me alone. You guys kind of with me. So don't sit there and go, I'm not going to do any of it because there's too much of it. That doesn't make any damn sense. Do as much as you can. Do as wide of a swath as you can. Skip some. That's, Okay, maybe. Okay. All right. So if there's no other questions, let's come back to this. Does anyone need this paper? We did this problem, these problems last time. Does anyone need this paper here? You do? Okay. Strangers in the night. Anybody else? Okay. So let's see, let's do this. Last time we did these two because they were the newest things we had just done. We've talked about these kind of problems before. Can everybody go ahead and do these 2 problems? Feel free to help each other out if you want to. I'm not going to force you to. Do those 2 first problems. and then we'll do it together.
We're crooked, huh?
It's fine. It has to be a little crooked just to capture the whole
Oh,
screen.
I
Yeah.
see, yeah.
Oh, let me get this out of the way here. I always forget. If you forgot how to do it, we're not doing a quiz. You can take a little peek at people near you. You can even ask them, hey, man, how do you do that first? Just to make sure everybody's on the right track, what's the first step on part A?
Square root.
Yeah, don't foil this out, right? You're kind of going backwards. It would eventually work, but it would take you a lot longer than if you just square root. Now we are taking a square root, therefore, plus or minus.
Mm-hmm.
So on this side, they just cancel. On this side, you get plus or minus square root of negative 28. And just to point out, you can do something here, yeah? Just to make sure everybody's on the right track. Okay, keep going. You can simplify this, yes? You should probably do that. How can I split this guy up?
7 times 4.
Yeah. What's the square root of negative 4?
2y.
Square root of 4 is 2. The square root of negative 1 is I. Kick ass. What's the square root of 7? I don't know.
Root 7.
Just leave it there, yeah. Let me stop for a minute. I think you all are cool with the first step, no problem. If I see a bunch of shit squared, I can square root it so I can free the shit up, right? When you take a square root, plus or minus, I think I've drilled that in your head enough. But it's just like if you told me the answer is 12 over 14, you could be right, except you haven't reduced it. So I always think of this as reducing the radical. So just like you would reduce a fraction, you must always reduce a radical if you can. Meaning split it up, do the part you can, leave the part you can't. How far away from the answer am I? Can anybody see? How many things do I have to still do? 2 things.
2.
Yeah. And of course, I've given myself no room But I'll be okay. I'm going to put it up here and then do this later. So what do you guys suggest I do next?
Bring the one over,
By doing what?
subtracting it.
Yeah. I left my eye out. That sounds terrible.
Can you put the eye on the end outside of the,
The reason we don't, real quick guys, the reason we don't, so if I have this and I write this like this, do you see how that could sneak inside of the radical?
okay.
In fact, one of my students a while back got a really good idea. Is like, why didn't we make the symbol have a back wall? And I'm like, that makes sense. The reason we don't normally put stuff after the radical is because it gets sucked into the radical. And do you all agree I is weird enough already?
Sure.
So what do you think this is? All right, let's stop thinking about this. Weird. Okay. So you definitely don't want the I to be in the radical if it's not supposed to be, because good God, that's weird on top of weird. All right, last step here is divide by 2. Shebang, and I'm done.
Yay.
You could break this up if you wanted to. I don't want to, so I will. Yeah.
Is it the same kind of principle, but could you have the negative one after the radical? Or minus one?
Oh, yeah, you could have plus or minus 2. I write stuff with a minus 1. Yes, you could. Yeah, you could. We normally put the plus or minus in the middle of stuff, just so we don't lose track of it or something. It's just convention. That just looks wrong to me, but it's fine. Okay. You're all very committed to not letting me know how you feel about things. I understand. Does anyone remember how to do part B? Let me get somebody to tell me the first step. What you got? What's the first step? I kick ass. You want to raise it to a power that will cancel the 2/3. So you're going to raise both sides to 3/2. I want to point something out that's really easy to forget. What did we have to do on the first problem and why? Where did this plus or minus come from? We took a square root. What kind of power is a square root? No, square is a square. What kind of power is a square root? 1/2 power, correct? Now, does everybody agree that I would raise both sides to the 3/2 power, yeah? Let me write this again because there's not a room. I'm going to raise both sides to the 3/2 power. What does that 2 on the bottom mean? Square root. Holy shit. So we just took a square root. Did I write a radical symbol? No. But don't we know that a 1/2 power is a square root? We just took a square root because I raised it to some kind of an over 2 power. What do I better put here? Plus or minus. That's an easy thing to forget because we connect the plus or minus with the radical symbol. But a 1/2 power is a square root. So here, I'll help. I'll do half the problem, all right? I'll do half the problem. Yay, Jeff, it's always funny. Now, this side, what root am I taking? Square root of 4 is 2, and I'm going to raise that to the 3rd power, right? So the square root of 4 is 2, cubed is 8. So you can rewrite this as the square root of 4 to the 3rd power. The bottom is the root, the top is the power. So fractional power is really nice. Roots are on the bottom of plants, so the bottom is the root. Power is powerful, so it's on top. Yes?
What is the plus or minus for?
Are you cool with the plus or minus we put here?
Well, yeah, I kind of get that because you got rid of the negatives on both sides.
No.
I guess,
Can somebody explain why I have to put that plus or minus there? No, I don't know. You just told me to, so.
because you're square rooting.
Yes, and why is that? So if I said x squared equals 9, you can just think of the answer. You don't have to do any math, correct? What do I square to get 9? 3 or? Ah. So taking a square root, in a sense, is actually sort of a shortcut. I got to remember, oh shit, there's 2 possible answers when I do that. I have to put the plus or minus. And any square root will be represented as a fractional power with a 2 on the freaking bottom. So if you ever raise something to a power that's over 2, I've got to put plus or minus. You just took a square root. You guys kind of with me. Again, this is another reason why I wish radical notation never existed, because then we would just be more like looking for the over 2 instead of the radical symbol. Okay, maybe? Alright. So we guys look a little catatonic, but we'll be okay. So coming back to this problem, what do you get here?
8.
Yeah, 2 cubed is 8, so I got plus or minus 8. And then what do you do then?
Add
Yeah, so you can even do this if you want to be safe. Right, plus or minus 8. So x equals 10, or x equals negative 6. Now, I circled those and I really shouldn't have. Well, we're okay actually, because it's a cube root on the side. We're okay. Real quick, if I wanted to stay real, can I do the square root of negative 4? If I need the answer to be real, can I do the square root of negative 4? No. If I want to stay real, can I do the cube root of negative 8? Of course I can. Why are cube roots so relaxed? I always think of like even roots are very hung up. They're very like, oh shit, they can't handle negatives. And odd roots are like, yeah, whatever. Because what is negative 2 squared? Positive 4. So it loses the negative. But what's negative 2 cubed? Negative 8. It keeps the negative. So odd roots can handle negatives. Even roots can't. That's why they're more like, I can't do it. Okay, maybe. Okay. That one's one of the weirder problems. You don't have like a ton of those, but they are exactly related to radicals because that's all fractional powers are radicals. Okay. We did these two last time. So what I want to focus on right now is, let me see, can you guys do this first problem real quick here? Number 2A. Notice you have to do several things, right? So do all the things. So the only difference between solving equations and inequalities is when you divide or multiply by a negative. Did we do an example of that yesterday? Did I show you why that's true?
Yeah.
Okay, because I'm doing like similar stuff in several classes, so I'm like, oh, okay, did I do that? So, can somebody tell me what first step you took here? Subtract x, okay. Minus x, minus x. Yeah, add 5. Plus 5, plus 5. Now this is not the best way to have this written to graph it, because your brain focuses on the less than or equal to, but what's kind of wrong about the way that's written to be able to see what's really going on? What does this say? Can somebody read this for me?
A is less than or equal to x.
Now somebody else read it backwards.
X is greater than.
Yeah, so that's a better way to write it because our brain focuses on the symbol, but if the variable is not on the side, I might think the answer is backwards. All right, are we all cool with that? Are we all cool with that? Okay. If you haven't graphed it yet, go ahead and graph it. And then I want you to interval notation it. I like verbing nouns. I was freaking out. Yeah.
My brother used to work there, but then he can go just to leave.
Oh, that's fine. Yeah, we were there for like 9 months. My stepfather was like bouncing around jobs. Yeah, I like Clearwater. The little bit of time we were there.
He's always talking about like the town, like the Scientology people.
Oh. Yeah. It's a little crazy down there. I like to say that I did my time in Florida. So,
With them?
no, I mean, it's just because of Florida. Did my time there, so. If you like Florida, I'm sorry. It's a crazy, weird sinkhole thing happening place. Water bugs big enough to carry small children. How do you graph this? So I don't give a shit about 1, 2, 3, 4. You just put 8. There's 8. Which way am I going to shade? Yeah, because it's a little arrow that points you how to shade, right? What symbol's going to go on the 8?
Bracket.
Bracket. Kick ass. How do I make this into interval notation? I start at 8 and I go to
Infinity.
infinity. What goes on the 8?
Bracket.
What always goes on the infinity?
Parentheses.
If you ever put a bracket on infinity, I'm going to ask you to bring infinity to me the next day. Because you're saying you got to infinity, so you included it. And that's my guess. Pulp Fiction keeps coming up. Has anybody ever seen Pulp Fiction?
Yes.
Do you remember the briefcase and they open it up? And I think that's infinity in there. So yeah. That's my own guess. I know it was a light bulb. I don't give a shit. In the movie, it was infinity.
It's supposed to be a soul.
It is supposed to be so,
Right?
but I like it being infinity. What's weird about part B?
There's too many columns.
Yeah, holy shit. This we're gonna analyze this a couple times throughout the semester, but this is kind of like, have you ever seen a situation where to play in this league, this baseball league, there's a minimum age and a maximum age, right?
Yeah.
So obviously they don't want some little 7-month-old out there. So they'll say you have to be between 5 and 12 or whatever, right? So it'll be 5 less than or equal to X less than or equal to 12. So it's like a bounded value. You guys kind of with me? So this is -4 is less than that business is at most 11. So that business is at least -4 and at most 11. Not including -4. Okay. So what the shit do you do? So if I just cover this up for a second, what would you do first? You would subtract 3 from all sides. We normally say from both sides because we normally only have 2 sides. But now, I'm going to subtract 3 from all sides. All right, keep going. I'll wait. I got you started. I kind of want to see that toddler baseball league then.
Oh, I got a visual.
Some parents like, come on.
Yeah, right.
Now there will be a weird thing you have to do at some point. You're gonna get a fraction, but I want you to realize you don't give a shit because once you get it, you're done. You don't have to do anything with it. So that's the greatest place to get a fraction is at the end of a problem. So I get -7 less than or equal to -7x less than less than or equal to 8. You can do it, Jeff.
8.
Okay. Trying to get x by itself. None of this tells me what to do. This tells me what to do. Well, how do I get x by itself? So we are dividing by a negative number. What does that mean I have to do? Flip the sign, yeah? I have to flip the inequality symbol. I got a fraction, I don't care, because I don't have to do anything with it, right? Now, this is still kind of written. Do you guys see how this is written out of order? So it's just a little better for me just to take a moment and just mirror reflect it. So it looks like it's more in the right order. Do you guys see that? Did I talk to you about why we flipped the inequality symbol? I did. Okay, good. So I would write this like this. If I read it this way, it says negative 8/7 is less than or equal to x, which is less than 1. Now that looks better, from smallest to biggest, right? So how do I graph it? That's right, kids. You put a negative 8/7 and a 1. What symbol goes on the negative 8/7? Bracket. What symbol goes on the 1? Parenthesis, and then I just fill the middle so that's like a sandwich with some jelly in there. Aha! And the really funny thing about these kind of problems is the interval notation is staring you in the face, right? It'll be bracket, negative 8/7, up to 1 parenthesis. That's why we don't do the open circle and the closed circle anymore, so it just flows right into interval notation. Let me stop for a minute.
I was gonna ask you why you can do the open or closed circle.
Yeah, so if you want to do an open circle, we actually now do parentheses. So parentheses is like half of an open circle. The bracket is like a closed circle, and it's when I want to include something, and the word include starts with an I, and the bracket looks like part of the I. So the bracket means include because it looks like part of an I, and the parenthesis means don't include because it looks like part of an open circle. Okay. Can anyone explain to me what the shit this means? In the context of this problem, what the hell does this mean?
Those are where our solutions.
Yeah, and let's be a little more specific. Do you know what number I can plug in and make this work? Can somebody give me a number that would make that inequality true?
0.
0. Kick ass. That's the one I would pick too, because it's definitely in between these two, yeah? What about negative 1?
Yeah.
It's in here because negative 8/7 is less than that. It's in there. You guys see what I'm saying? So any number that's in the jelly here will make that inequality work. Will make it true. So what would happen if I put a 2 in there?
No.
Whatever statement I end up with would be untrue. The untruth. Okay. I like it. Maybe. Okay. Alright, now we haven't talked about this weird shit yet, so let's talk about that. That's some weird shit. Let's talk about it. Okay. Somebody remind me. Let's do a little example of a nice little, what do you call it? You can do it, Jeff. Gather. An equation. An absolute value equation. Can somebody remind me how to solve this? Can I just add 1 right now?
No.
Why? Because
eight
this-
can also be negative. 8 can also be negative.
Oh, I see what you mean. Well, more directly, 3x minus 1 is stuck inside of an absolute value. I can't break into that. So how do I get rid of the absolute value? How can I rewrite this? How do I rewrite this?
3x minus 1 equals
Yeah.
6 minus 8.
If I just ask you, what do you take the absolute value of to get 8? What's the obvious answer? What do I take the absolute value of to get 8? Just give me a number whose absolute value is 8. 8. Kick ass. Give me the other one. Negative 8. Good. So I desperately want you to understand. 3x minus 1 is a number, yes? So, and this problem says it wants the absolute value of that number to be 8. So what could that number be? That number could either be 8, or that number could be negative 8. And that's why we have 2 cases. Either this number is freaking 8. If that number is 8, this is true, obviously. If that number is negative 8, then the absolute value would strip the negative away and make it 8. That's where those two cases come from. And now I can solve these. Add 1, I get 9. Divided by 3, I get 3. Add 1, I get negative 7. Divide by 3, I get negative 7 thirds. Okay. Alright. And you're all like, that's nice, Jeff. But the problem on this side is got an inequality. Oh, shit. Okay, let's talk about that. Let's just look at this. Oh, let's look at this. Yeah, I like it. What does absolute value mean again, physically?
Distance from 0.
Distance. I love it. Not necessarily from 0, as we'll see right now. Absolute value means distance. This problem says it wants all the numbers that are at most not quite 4 away from 1. Isn't this like x? If you did 7 minus 1, doesn't the number you get represent how far 7 is away from 1? So subtraction deals with figuring out distance. When I take an absolute value, it makes it actually be distance. I can have a negative. I live about negative 10 miles away from here. What the what? What? In a portal? Get out of here. All right. So distance can't be negative. That doesn't make any sense. So let me say this. This one says the distance between a number and 1 is kind of at most 4. So I can't get further away from 1 than 4. So let's figure out the answer less algebraically, more visually. So here's 1. If I can get at most, let me here, everybody just do this for me, just so I can stop trying to, can everybody just make that less than or equal to? Just so my language is a little bit more direct, okay. I can get at most 4 away from 1. So how far up can I go? I can get at most 4 steps away from 1. So how far up can I go? 5. How far down can I go?
Negative 3,
You guys with me? So what's the answer here? Negative 3 to 5. Why do we not always just do this? Because the inside's not always going to be this nice. So now let me show you the algebraic way to solve this. We already know what the answer better be. If we don't get this answer, and what we do, we can throw all of this out and go home. That's where I see a couple people kind of like perk up. Oh, really? So help me out. This number can be at most 4. Or at least, so let me ask you this. I knew I should have started with, that's okay, Jeff, you'll be okay. So if I had, don't even write this down. If I had just this, what's the biggest number? Let me make this, there we go, Jeff. What's the biggest number you could plug in to make it true? Can you plug 6 in? No. So what's the biggest number you can plug in?
4.
What's the smallest number you can plug in? Yeah, because if you try to plug negative 5 in, what happens? The absolute value of negative 5 is, and is that a true statement? No. So do you guys see how by itself, I can tell the answer is negative 4 to 4. Yeah. So algebraically, how could I rewrite an inequality with a less than? I could rewrite it as this number can go down to negative 4 or up to 4. If it goes above 4, it's not a true statement. If it goes below negative 4, it's not a true statement. So this number can be at most 4 or at least negative 4. I can immediately rewrite this as this. Do you see how I still have 2 cases? Absolute value will always have 2 cases. And how do I solve this? Add 1 to all sides. Do we get the same answer we got earlier? Thank you, gods. Yes, we do. Okay. I like it. I think of an absolute value less than to be like going into a haunted house or something, right? We're not in the movies. What do you not want to do if you go into a spooky place and you're in a horror movie? You don't want to split up. You want to stay close to each other, right? So when I see this, this says the distance between you and me is at most 4 feet. That's the way I look at this. I want the distance between us to be less than or equal to 4. I want us to stay close to each other. You with me? So I think of a less than absolute value stuff as being stay close to me. So see how the picture we get? Let me make this picture a little better. -3 to 5. See how it's a sandwich? Stay close to me. Go up to 5, go up down to -3, but don't go any further, man, because holy shit. You guys coming with me? You've got the flashlight. If you get more than 4 feet away from me, I can't see anything. Good Lord. Okay. Maybe. All right. So what if it was a greater than? So let's see, what if we had 2x minus 5 is greater than 11. I apologize in advance if this hits too close to home, but for anybody who's ever gone through anything, I think of this problem as a restraining order. I want the distance between two things to be at least something. Stay the shit away from me. You guys with me? Absolute value is distance. So this statement says I want a certain distance to be more than 11. You can't come closer than 11 feet to me. You got to stay back. That's a really weird restraining order, but yeah. You guys kind of with me? So I expect the picture we're going to get, look. The picture we're going to get should look like this. It should have something like this. Stay away from me, right? So I'm in the middle, I'm safe, and the closer you get is out there. Okay, so let's see what happens. So let me ask you this. If I just put this, okay, let me see. 11 is a bad choice of a number. If I put absolute values, what is the biggest, I'm sorry, let me say this again. How do I say this? What's the smallest positive number that would work in here? That would make this true? Try to plug a 9 in. Is it true? No. So the smallest positive number that would work is a little more than 11. Are you guys with me? 12 works, 13 works, 9 doesn't work, 10 doesn't work. What about negative numbers? Can somebody give me a negative number that would not work? Give me a negative number that you plug in there and it's not true. Negative 9. Because what's the absolute value of negative 9? 9, which is not bigger than 11. So so give me one that does work. Negative 12 billion. That's right, negative 12. Absolute value of negative 12 is 12, and that's bigger than 11. So can you see what's got to be true? What kind of number can you pick? It's got to be at most almost negative 11, correct? So what am I saying here? I don't know. This number either has to be, what was true for the positive numbers? It had to be more than 11, correct? 12, 13, that works, but 9 doesn't work. It must be more than 11, or this number must be less than negative 11. Absolute value, 2 cases. I always get 2 cases. And just to help you out, what's this symbol again? Great Tor, then. Yeah, great Tor, or less than and. Yeah, I'm not going to focus too much on that, but okay. The great Tor thing is good. The less than, I always remember to make sandwich.
Yeah. Yeah,
I don't want to get too much in the and intersection business. You guys semi with me? So the algebra is built on the back of just what the shit makes sense. 2x minus 5 is a number. We just talked about what numbers would work. So then we just write that in Mathish. So now I've got 2 problems to solve. Add 5, divide by 2. Jeff, you can do it, buddy. Add 5, divide by 2. Is that all right? I mean, once you get to that step, it's like, thank you, God. You just got to solve this thing. Not a big deal, right? Can you graph that? This is one answer. I want one graph. Can you graph? Can you graph it for me? Graph. Pretend like it's 2 things, but then put them on one number line. So it got to be greater than 8. So put 8 over here. What symbol's going to go on the 8? Parentheses. Or I got to be less than -3. So again, same idea. Parentheses. Do you see how that looks exactly like? And of course, I knew what the hell it's going to look like, so I can push this in the right direction. But still, stay the hell away from me. Doesn't this look like, if you're like, all of you stay away from me, wouldn't you do this? This is something you could do mathematically. Look, it's freaking stay away from me, right? That's exactly what this dude's saying. I'm here in the middle, and I'm like, stay away from me. You know, it's just, are you with? Okay. How do I write this in interval notation? What's this piece look like? I start where? Negative infinity up to
-3.
with a parenthesis. Does someone remember what or looks like in symbols? Yeah. If I was like, you or you, somebody, clean the room. Hey, look what I just made. I made a U. So that's, it stands for union. You don't have to worry about that. So that I think of that as or. So my answer can come from this set or from this set. I want to point out, if from the beginning I had put less than, my answer would have been in the middle here. You see that? Okay. So sandwich for less than, 2 separate parts for greater than. All right. So, what have you done, Jeff? There you go. Look at this problem. 2C. What do you think you should do first? You got to isolate the absolute value. I love it. There should be 2 things you do to get the absolute value by itself. So go for it. Try to get the absolute value piece by itself. Yeah.
Do you distribute the negative or do you divide by a negative?
You can't distribute the negative because you can't go into or out of an absolute value. You're going to have to divide it. Yeah. In which case, you got to be careful. Because you have an inequality. So right here, you have to divide by -1 to get your absolute value by itself. But when I do that, what has to happen? I didn't really mean to make this one this weird. Shoot, Jeff. I really should think ahead when I do this. This specific problem, you don't have to do any more work. Let me see if I can get you guys under it. I didn't mean to make this problem come out this way. Do y'all agree that one side of this inequality says the absolute value of a number? Right? Absolute value 2x plus 1. That's the absolute value of a number. So what's the whole thing say? It says the absolute value of a number is bigger than -1. Is it ever possible for that to not be true? What's always true about an absolute value? What's the smallest that an absolute value could be? 0. Is it ever the case that an absolute value of something would be less than -1? Do you guys agree then that this statement is always true? I don't care what I put in for 2x plus 1. Isn't this always true? Isn't the absolute value always bigger than -1? You guys don't like that one. Okay. This inequality says, what do I make x so that the absolute value of this thing is more than -1? It's always more than -1. Absolute value of anything is more than -1. Because it's at least 0. Absolute value can't be negative. So how could it be not greater than -1? So this specific problem The answer is all real numbers. If this would have said less than, could the absolute value ever be less than negative 1? Can the absolute value ever be less than negative 1?
No.
Because the absolute value is always not negative. It's always positive or 0. You guys have a hold with me. I need you to see this. This specific problem has a special case because, of course, this is always true. I don't care what you put in there. It's going to come out positive. So it's bigger than negative 1, right? Okay, so let's pretend. Let's get another sheet of paper. And let's pretend like Jeff had thought ahead. It's kind of good that that happened because you're going to see at least like one problem like this in the homework where the answer you don't have to do any work for. It's sort of like, just to remind you guys, what if I put this problem down? Do you have to do any work? Does anyone already know what the answer is? No solution. No solution. Because the square root is defined to have a positive output, right? The square root can't be negative. So I don't have any work to do. It's the same as this problem. I have no work to do because the way it's written is impossible. Okay. So let's pretend like I had made the problem. Oh, I forgot where the problem is. What was it? 2x plus 1 inside? It ended up being greater than, right? Yeah, let's just say greater than 1. Okay. So is this going to be a stay close to me situation, or is this going to be a stay the hell away from me situation? A sandwich or a get away from me? Haunted house or a restraining order? Restraining order, yes. It's great. Tours, or get the hell away from me. I want the distance to be bigger than something. Go. Okay. So what are my two cases I could write then? Wait a minute. Give me one moment. Oh yeah. We haven't done that yet. That's why I wanted to do it. Okay, we did. Okay. So what are the two cases? Who remembers? So either one case kicks ass. One case just says if the number is already bigger than 1, then obviously this is true, yes? So one case leaves everything the same. Or the other case is this number could be less than negative 1. So one case is leave this exactly the same. The other case is change this entirely. Just to remind you, if I made this number 2, it would work. Any number bigger than 1 would work. If I made this number negative 1/2, is this true? If I put a negative 1/2 in here, what's the absolute value of negative 1/2? And is that greater than 1? Is 1/2 bigger than 1? No. So therefore, the number has to be less than negative 1 in order for it to work. So it could already be bigger than 1, or it's got to be less than negative 1. So when I take an absolute value, it ends up bigger than 1. So we have a great Tor. One case is leave it alone. The other case is change both things. And now I just have two little dudes to solve, right? So here, what do you get? 0. When you divide by 2, it's still 0, right? And over here you get -1. Do I have to flip the sign? Should I flip the sign? So some students, they key in there is a negative in the problem, but it's if I divide by a negative or multiply by a negative. And I didn't. I divided by 2. All right, so take a minute, graph it, interval notation it. greater than 0 or less than negative 1. So then this is basically, or this one is going to start at negative infinity up to negative 1. And I already know I'm going to use a parenthesis. And this one's going to start at 0, go way up to infinity. Okay, not too bad. When you have a greater, stay away from me. When you have a less than, stay close to me. That's section 2.7. Section 2.7 is inequalities and absolute value inequalities. So we're going to get a little bit into chapter 3. And then we're going to call it a week. Can't believe it's already a week down, just holy shit. All right. I think we've done, let me write this down. What does this mean, this symbol?
Function.
Yeah, how do you read this? F of x, I love it. So this is not f times x, right? This is f of x. So, I mean, we've seen stuff like this before. So using function notation is really straightforward. It's just substitution. So what would f of 3, how would you figure out what f of 3 is? Yeah, it's kind of nifty. I replaced x with 3, so I just replaced x with 3. So that's all function notation is substitution. 3 squared minus 5, 9 minus 5. What about, what's f of m? Yeah, m squared minus 5. Right? What's f of Jeff?
Jeff squared minus 5.
Jeff squared minus 5, yeah. So, I mean, that's all the freak function notation is. It sets up what to do to the input. So if I have an input, I do that to it. That's kind of silly. But let's talk more fundamentally. Not everything we look at is a function. Does anyone remember what it takes to be a function? What actually it says something is a function? Sorry, I went too fast. What does it take in order for something to be a function? So let's talk about this. If I throw a ball, somebody throws a ball, and I'm like, okay, 2 seconds after you threw it, where is it? And they say 7 feet up in the air and 20 feet up in the air. Let me say this again. Somebody throws a ball. And 2 seconds later, I'm like, where's the ball now? 7 feet in the air and 20 feet in the air. Does that physically make sense? No. If I ask somebody, hey man, what size shoe is on your left foot? And you say size 8 and size 12. I'm like, what the shit? Did you put a shoe inside? What are you talking about? Does that make physical sense? No. So in a lot of applications, when I have one input, 2 seconds later, 2 is an input. Left shoe is the input. I can only have one output. If I had 2 outputs, that would be freaky. Right? You guys got it with me? Is that right? Okay. So a function is a relationship between an input and an output. Holy crap, Jeff. An input and an output. Where for every input, there can be only one output. That's the heart of it. It's a relationship between an input and an output where for every input, there can be only one output. I don't know if anybody's ever seen Highlander, but that's what I always think when I do this. There can be only one. Okay. No prerequisite for this course is you watching anything, so you're fine. I keep referencing these things. You don't have to watch. So what the shit? So that kind of makes sense. So when I ask you 2 seconds later, I expect you to tell me one number. If you tell me more than one number, I'm like, what kind of ball is it? What the shit? Is it a portal ball? What's going on? Okay. You guys kind of with me a little bit? So what does this mean visually then? Let me go ahead and give you this. So you don't have to suffer through me trying to draw, which is a horrible thing for anybody to undergo. Sure. Count. My job would be easier. So coming off of that definition, to be a function, every input can have only one output. That first picture, does it represent a function? Can somebody tell me why not? Ah, beautiful. Okay, so we're trying to build up to that. So, does this input have more than one output? Yes. So do you see how you naturally kind of make a vertical line? Do you guys remember the vertical line test? It is just a visual representation of the definition of function. Holy shit. It's a visual representation of the definition of function. If I draw a vertical line, that represents one input. If it hits the graph more than once, that's more than one output. So that first graph is not a function. Nope. What about this dude? This dude, I don't see any vertical line that goes through more than once. Check. What about this dude? Anybody know what function this is? This is a graph of a specific function. That's absolute value. Kick ass. Okay. The reason it's negative is because it's probably absolute value minus something. So, all right. Check. There's no vertical line that goes through more than once. What about this dude, of course? He fails. You get out of here. No. Okay. So visually it's nice. The vertical line test, if I give you a graph, that's all you got to think is, do I see any vertical lines that go through more than once? So it can't kind of like come back on itself. So this is like, at 2 seconds, where's the ball? It's here, and it's underneath the ground. What? Okay. So that's one level, is just why the hell did we make the word function? What does it mean? It means this. Every input can have only one output. Then, of course, you guys know this. The domain and range is kind of like the next thing. I think my printer's finally given up a little bit. It's not too bad yet. What's the domain? Well, I say it here, don't I? You just read. The domain is the collection of all the inputs that have outputs, and the range is all the outputs. So for that first problem, this is a way I can define a function. All a function is, all a relationship is how does x become y? So on the first one, 1 would become -3. Do you guys see that? Can somebody tell me, does that represent a function? And again, what's a function? Can I do vertical line test? I don't want you to graph those things. You could, but why would you? What do you think instead? What's the definition of a function? Every input can have only one output. So does 1 have more than one output? What's the output for 1? Does 2 have more than one output? Does 3 have one output? Okay. Does it matter that? Come on, Past Jeff. Oh, you suck, Past Jeff. Oh, shit. That's okay. So this one is yes. What if I made this problem that Past Jeff should have done? But he's not very smart. Let me save something from yourselves. This is a function, but can somebody identify why somebody might say this is not a function?
Because the two outputs are the same.
Two outputs are the same. But what does it take to be a function? Every input has one output. One has one output, two has one output, three. It doesn't matter that one and two both have the same output. If I throw the ball and I say, where is it 20 minutes later? And you're like, it's 0 feet off the ground. How about 21 minutes? It's 0 feet. It's just sitting there. Does that physically make sense? This paper. How tall, how high from the floor is it at 1 second? 2 feet. At 2 seconds, 2 feet. It's fine to have the same output. That makes physical sense. So when I give you a collection of points, what do you look for? A repeated input. So for example, if I gave you this problem, Jeff, you could do it. Can you guys see that? Why specifically is that not a function? Why specifically is it not a function? 1 has 2 outputs. 4 happening twice doesn't matter. 1 has 2 outputs. Yeah, like that. Okay. So what about this formulation? There's another way I can define a function. What do you guys think this circle represents? Oh, by the way, the whole point of this is to find the domain and range. I get so hyped up on functions. Looking back at number 1 real quick. What is the domain of this problem? What's the domain? Yeah, and be really careful. What's wrong if I write like this? What's wrong with that?
That counts for every value in between.
So 3.781111111114 is no, that's no good, right? So you have to do it like this. So what's my domain? 1, 2, 3, 4, 5. So I have finite inputs. And what's my range? My range.
-3, -1, 1,
All right, sweet. Domain, all the inputs. Range, all the outputs. What do you do? So here, this is a function. All of these are functions. The point is the domain and range, Jeff. You'll be okay. So I kind of gave it away a little bit. What's the domain here? 1, 2, 3, 4. What's the range?
0, 1, 2, 3.
How could you redraw this so it would not be a function? What's one thing you could add, bless you, so it's not a function?
Put an extra arrow on.
Yeah, if I took an extra arrow, if I did an arrow from 1 to 1, now this input would have more than one output. So they all have the same definition. It's just that the different ways I can give you a function has a different way to think about it. Well, now you don't want to do this. Because, for example, does I'm sorry, that's a bad example. Does 1 point, no, it's not a bad example, Jeff, you'll be okay. Does negative 1.29876 have an output? Of course it does. So here's how I look at this problem, really quickly. Domain is related to which variable, normally? X, my inputs. So if I have a little dude walking, where's the first time he sees the function? At -4. So that's the first input that has an output. Is it a closed circle? If it was open circle, I could not include that, right? So the domain is from -4 to what? Where's the last place this little dude would see it, looking up and down? At 1. After that, he loses it. Literally, because he's stuck on a freaking graph. That's weird. So what do you think I have to look at the range? I have my little dude walk along the y-axis. So what's the first time he sees it looking left and right? -5 is the first time he sees it. And what's the last time he sees it? 4. So the range, here's the domain. The range would be, I just forgot what I said, -5 to 4. You guys all right? Yes.
I wrote it in a different way.
Oh, did you use like -5 less or equal to y, less or equal to 4? Okay. We had that question yesterday, I think, and that's fine. Just interpolation is the most concise way to write it, but if you wrote it like that, I'm fine. Especially if you had a teacher that kind of like really make a big deal out of it. Okay.
Okay, so you said at the like in the first one to not use the square brackets, right?
Hell yeah.
But then why do we use square brackets for the bottom?
So again, on this problem, does 0.876 have an output?
No.
No.
Okay.
On this problem, does 0.876 have an output? Yes. Do you see how this is filled in? Which means every single little pixel in there, and how many pixels are there? Infinite number. So if I did it this way, it would take the rest of my life and the rest of my kids' life, because I would bequeath them with this job to write all the answers. So I'd much rather just do this, which means every damn thing between those, yes? So when you have distinct things, set notation, right? When you have continuous line, interval notation. So what about this guy? What's the domain? Oh, sorry.
I was just wondering, is the closed circle also why we use brackets for range? Or is
Oh, hell yeah. Yeah, so like if I had an open circle right here, then I would have put a parenthesis on -5.
But
And I would have also had a parenthesis like a -2.
so if there was an open circle at -4 though, it would
Oh,
also count for that?
The range would be cool because the range, there is a -4 output. Do you see that? So if that was an open circle, the range would be exactly the same. Because there is a -4 output.
So in this case, how do we know to use brackets?
If that input or output, if the input's not used, or if there is no output there.
Oh.
Yeah. Okay, I like it. Oh. So like if this had been an open circle right there, I would have put a parenthesis here, and I would have put a parenthesis here. Yeah, because that's not an input that's used, and it's not an output I attain. Yeah, yes.
Could it also mean that because it's like open circle means infinity, right?
No.
No.
Open circle just means there's no output there. That input does not have an output there. Yeah, that's all it means. Yeah. Infinity would actually be like an asymptote. You just go up forever. Oh. Pull up. Subtract. Okay. All right. This is a good, beautiful example. Because what's kind of like, what do you key in on? The fact that there's an open circle. Oh shit. So what's my domain? What tells me my domain is more than -6? I go further because
The arrow.
So what's my domain start at?
Negative infinity.
-infinity. Do I go all the way up to infinity?
Yes.
No.
Nope.
Because where do I have to stop?
Stop first.
Or the open circle.
I have to stop at 2. Then pick back up at 2 and go to... So if I stop at 2, but then I pick back up at 2 and go to infinity. So I always think about this piece here as saying skip. So it's -infinity to infinity, skip 2. So the range is going to look very similar, right? What's the one value I've got to throw out of my outputs? Jeff, I love you so much, man. You're my favorite person ever. What should I have put here? Negative what?
Three.
-3.
Oh.
I have no idea where I got 2 from. No idea. So -3. That is fascinating to me. I have no idea why I did that. Oh man. A few more years. I'll be out there, "Oh, what did I say? So, okay. So let me make sure you guys understand. The -3 input has no output. So I see what I did. My brain just saw that too there. All right, I feel a little less bad. Okay. -3 is not an input that's used, so I must throw it out of my domain. What's an output that does not happen? -2 doesn't happen, so I must throw it out of my range. So again, I look at this piece right here as saying skip. -infinity to infinity, skip -2. All right, I'm a little less worried about myself. Okay. Oh, it's basically time. Real quick, we'll finish this up next time, but what is f of -1? Did I give you a function on this one? Did I tell you what f of x is? Nope. Damn, Jeff, I did better than that shit. The work's done. Somebody's already done the work. You should be very happy. Can anyone tell me what the f of -1 is, looking at the graph?
2.
Yeah, f of -1 must be 2 because that's where they put the frickin' point. So that's the whole idea of a graph. Here's all the answers. Find whichever one you want. So f of -1 is 2. And then, same idea. Okay, so we'll finish that up. Monday, first thing Monday, of course, is the quiz. Yay! Our first graded thing. Oh, I'm sorry, real quick. Tran? Hey! Go ahead, what's up?
I have it on this